All right, so now it's time to visualize our mean squared error cost function. Now, I don't know about you, but I can't look at these equations and picture what they actually look like in my head. I'm the kind of person who really needs a graph or a chart or something visual to really understand what's going on. So let me insert a subheading here with markdown, 2 pound symbols, and I'll just write 3D plot for the mean squared error cost function. And let's have a subheading here that reads make data for thetas. The first step in creating our plot is to create a whole range of theta values that we can use to calculate the mean squared error for. So remember how I said that the cost function depends on the parameter values and not the data itself, not the x5 or the y5 arrays, but it depends on the theta. That's what the cost function is trying to map. The first thing that I'm going to do is I'm going to set the number of data points for our chart. I'm going to call this number thetas. It's going to be a variable, and to start off with, I'm going to set it equal to 5. And then I'm going to create our data points. So I'll create a variable called th_0. I'm going to set that equal to the return value from numpy's linspace function. So it's going to be np.lin space parentheses, and then we're going to supply 3 inputs. Start value, we're going to say -1. A stop value, we're going to say is equal to 3, and a number of intervals, so the number of points that we're going to create. And we're going to set that equal to nr_thetas. So that way, when we look at th_0, we see that it has 5 values. It's an array of 1, 2, 3, 4, 5 items. I'm going to copy this line of code here, paste it in, and have the same thing for theta1. Theta1 is also going to go from -1 to 3, and it's going to have 5 values. So what we've done here is we've created a one-dimensional array, but we're going to have a 3D plot, so we're going to need a two-dimensional array. We're not plotting a line, we're plotting a surface. And for these, we need an array of 2 dimensions. The way we're going to create a two-dimensional array is by using numpy's meshgrid function. So we've done this before, and just to differentiate between the one-dimensional and two-dimensional variables, I'll create another set. So I'm going to say plot t0, comma, plot underscore t1 is equal to np meshgrid. So meshgrid is the function that will give us a two-dimensional array. And we're using this comma notation, plot t0, plot t1, as a way of unpacking a sequence, because meshgrid will return to us a tuple. Meshgrid in turn needs 2 inputs, so it's going to be theta0 and theta1. From these inputs, it's going to create our 2D arrays. So if we look at th_0 dot shape, we'll see it's a flat array, one-dimensional with 5 elements. And if we compare that to plot underscore t0 dot shape, then we see that it is a 5 by 5 array. So it's two-dimensional and has 25 elements total. So if I delete the dot shape and I press Shift Enter, I can see it here. It looks like this: 5 by 5, 25 elements total. Now it's time to calculate the mean squared error for all the theta0 and all the theta1 values in our range. So let me ask you this. Do you think that the cost that we calculate will have 1 dimension, or will it have 2 dimensions? And the answer is it's also going to be 2-dimensional. The surface plot needs to know the mean squared error value for all the combinations of theta0s and theta1s. We're going to be plotting a surface, not a line after all. So here's what we're going to do. We're going to start out with a 2-dimensional array of just zeros. And then we're going to calculate the mean squared error for each value in our array separately. This will give us a chance to learn about another Python programming technique, which is very, very common, and that's using nested loops. Let's add this as a subheading, actually. So I'm going to change this to Markdown, 3 pound signs, and then I'm going to say calc MSE using nested for loops. Going to add a few more cells down here, keep working in the middle of the screen. And the first thing I'm going to do now is I'm going to create a 2-dimensional array just of zeros. So NumPy actually has a function called zeros, which is perfect for this. All we need to do is supply the dimensions of the array that we want as an output. So the variable that's going to hold on to all our mean squared error calculations is going to be called plot_cost, and that's going to be equal to the return value from this zeros function that I mentioned. So np.zeros, parentheses, and then inside the parentheses, we supply the dimensions. So if I supply 2 by 3, so 2, 3, and then say plot_cost, I can see what a 2 by 3 array of zeros will look like. It'll be 3 columns and 2 rows. So 2 rows, 3 columns. If it's 5 by 5, on the other hand, it'll be 5 rows and 5 columns. Now, I'm not going to have a hard-coded 5 in here. Instead, I'm going to use the number_thetas variable and feed it as an argument to our zeros function. So what I'm going to do is I'm going to supply a tuple, which you can see by the 2 parentheses, and it's going to be square. It's going to be symmetrical. So it's going to have the same number of rows and the same number of columns. So it'll be nr_thetas, nr_thetas. So this is going to be the input to our zeros function. So if I ever have to change my variable up here and update this cell, then my plot_cost will update as well. Now it's time to talk about nested loops. Let me add that as a comment here. See, nested loop practice. And let me show you what I mean. So to create a nested loop, we're gonna use 2 for loops. So the first for loop is gonna look like this. It's gonna read for I in range, and then say the number 3 between the parentheses, then colon, and then inside this for loop, there'll be another for loop. So I'm gonna write for j in range, parentheses, 3, colon. And inside the second for loop, I'm going to put a print statement. So let me print the string hello and hit Shift Enter. And what we see is that hello is printed a total of 9 times. So 3, 3, and 3. 3 times 3 is 9. So this is how many times we print hello. Let's go a step further than just printing hello 9 times. Let me show you another way of doing string interpolation with Python. This is a different way that we can work with strings from what we've seen before. This particular method is called an F string. It's an F string because there's an F right in front of the string. So it's going to be F, and then you have the single or double quotes. And then within the string itself, I'm going to say value of I is, and then I'm going to use a set of curly braces. And inside these curly braces, I can access a variable in my Python code. So for example, I can access this variable I here, the iterator, in my outer loop. So I'm going to say I in between the curly braces, and then I'm going to continue. And j is, and then another set of curly braces. And then inside these curly braces, I'm going to actually put the value j. So I'm accessing this variable, the second iterator, the one for the inner for loop. And now I'm going to hit Shift Enter. See what we get. So what we see here is that the values that are printed out from inside these curly braces change every time the loop is executed. By having this special notation, the F in front, and then the curly braces, we're able to tell Python that something inside this string should not be considered a string. Instead, we're able to reference values that are stored in variables elsewhere. Now, the other thing that's really, really cool about this particular pattern is that we can see what happened exactly when our loop executed 9 times. So before we had hello printed 9 times, but this time we can see what's actually going on and how these I and j values are changing. When the loop first starts out, I is equal to 0 and j is equal to 0. And then what happens is that the inner loop executes 3 times. J becomes equal to 1 and then to 2. And after that, it's done executing. And then the outer loop increments by 1. So I goes from 0 to 1, and then it's j's turn again. J goes from 0 to 2, executes 3 times, and the whole thing repeats one final time. So one of the things you can probably already tell is how this might be applied to many, many different kinds of problems. In particular, it goes very, very well with iterating through a 2D array or a 2D matrix. If you want to hit up every single value, then you can go row by row and column by column. And this is exactly what we're going to do. The important thing with this sort of stuff, as with all Python code, is to make sure the indentation is correct. And that way Python knows that this loop is indeed nested inside this first one.